So this section is over reviewing graphing lines as well as writing the equation of lines. So let's review here. So this is from Algebra 1. So at first you might be, oh, I don't remember how to do this, but after doing the notes, you probably should be able to know how to do this. So we are going to graph the line of y equals 2x minus 4. Now, one thing you need to figure out when you're graphing this is your slope and your y-intercept. Now, remember we had an equation, which is y equals mx plus b. This is what we call our slope-intercept form. In this case, m is what we call your slope, okay? There you go. And then b is what we call your y-intercept. Remember, the y-intercept is where your graph crosses the y-axis. So in this case, if we're following this form, m is our 2, so that means 2 is our slope. And remember, slope means we rise over run, okay? And then also in this case, our b value, or y-intercept, is -4, okay? So what you could do always here is you could graph your y-intercept and then use slope to basically graph the other points. Now here, I'm going to use an XY table to get some of the other points here. So I'm going to start with -2. Now you can pick any x values you want. I'm just going to pick these. So I have -2, we're going to go to 0, 1, and 2. There we go. So -2, how we plug it into the function we're evaluating so we can get our y value, okay? So we plug in -2 in for x. Basically what you're doing is you're doing 2 times -2 minus 4. And really what that should give us when we evaluate it is -8, because you basically have -4 minus 4. Okay, what if we plug 0 into here? So we do 2 times 0 minus 4. Well, that should give you your y-intercept of -4. What if we plugged 1 into our x value? That should give you -2. Okay, and then lastly, plugging in 2 for our x. So we have 2 times 2, that gives us 4 minus 4. That should give us 0. Okay. There we go. Okay, so we are now going to plot these points. So we have -2, -8, so that means we go all the way down here, plot your point. Then 0, -4, so we go 1, 2, 3, we go 4. Then we go 1, -2, and then we have 2, 0. Now all we have to do is connect our points. Make sure it's a straight line. Mine's not very straight, but I tried. There we go. Okay, there's a straight line. And then here is basically your graph. I'm going to darken the circles here so you guys can see. And so remember, that's how you graph a linear equation. So go ahead, I would like you guys to try to graph y equals 1/2 x minus 2. So go ahead and pause this video and try to graph this, okay? So hopefully you pause the videos to try to graph this. If not, okay, let's go over it. So remember we use the y equals mx plus b, that is our slope-intercept form. Now here's what I've got, okay? So basically our slope, our m is 1/2, our y-intercept is -2. So here I just picked any points. Now because we are doing a fraction, I wanted to pick numbers that are divisible by 2, which might give you nice numbers. You could pick other numbers if you want as well. So here are the x values I picked. You can pick any x values you would like. It does not matter. And then as you can see, I plotted my points here. And so what I'm going to do is draw my line from point to point. And then make sure, because this is a line that goes on forever, that you have your arrows at the end of your line, okay? If you do not, that means you're just creating a segment and it's not a straight line, okay? So there you go. So that is going to be our graph. And then make sure it's straight on yours. Mine's just a little bit wiggly, but make sure it's nice and straight. If you have further questions on how to graph lines, make sure you email me or come in before or after school. Now the next example, what we're going to do is we're going to do basically the same thing. But if you notice, when we look at example 3, we have y equals 2x plus 1. And now saying when x is greater than 2. Now when we see this little bunch right here, this is what we call a restriction. Okay. Basically, when it says when x is greater than 2, it's saying that we are restricting our line only from the x values of 2 and greater. Okay? So we're not going to draw like a nice straight line. We're going to start from one point and then just draw a line in the opposite direction. Basically, we are creating what is called the ray. Remember that from geometry? Okay, so here when x is greater than 2. Now this is very important when you're picking your x values, because what you have to do here is you have to start with your restriction. So that should be the very first number you pick, okay? You always have to start with this number, x here, okay? So now what we have to decide is, well, what other x values can we have? This is where we have to look at our inequality. This is saying x is greater than 2. So if it's greater, that means we want numbers bigger than 2. So let's go ahead, we're going to pick numbers maybe like 3, 4, and 5. That might work, okay? Okay, so now what we're going to do is take these x values and plug it into our function. Now, I think on your notes it should say 2x plus 1. If it doesn't, make sure you change it to 2x plus 1. So now we're going to evaluate. So I'm going to plug in the number 2 first, because that's our first x value. And when you do this, you should get 5. So we have our y value of 5. Now I'm going to plug 3. So I have 2 times 3 plus 1, which is 7. And then I plug the 4 in for x as well. So 2 times 4 plus 1. That'll give me, it should be 9, not 8, but 9. Okay. And then our 5. So we do 2 times 5 plus 1. That should give us 11. And it's okay if your points go off the graph a little bit. So now what we need to do is plot these points. Now, before we plot them, okay, we have to look at this inequality, because this point, in this case, is going to tell us if we're going to have what is called the open circle or closed. Remember when we had to do this with absolute value inequalities, knowing when we have an open circle or closed, we're going to do the exact same thing. So if we look at our inequality, we see that we don't have an equal bar underneath. Because we don't have an equal bar underneath, basically this point 2, 5 is going to have an open circle. So very similar to when we did absolute value inequalities. So whenever we did not have an equal bar, our points were always open. So when we plot 2, 5, so 1, 2, 3, 4, 5, make sure you have a nice open circle. Not closed, but nice and open. Now, for the rest of these points, we make them closed. It is really only the first point that is open. Okay, that's the only point that's open. Everything else has to be closed. So I'll kind of write this so you guys remember. So these are going to be closed circles. There you go. Now this is really gearing you up to what you guys are going to learn about piecewise functions. So that's why we want to learn about these restrictions first. So we go over 3 and then up 7. So this one is going to be closed. So make sure you have a nice closed circle at 3, 7. Then we have 4, 9. And then we have 5, 11. This is going to kind of go off the graph, but that's okay. Now, in this case, to determine, well, where do we kind of like have our arrow going at? We always start at our restriction to draw our arrow. So the first point that we plotted was 2, 5. So we start there, and then we connect every other point afterwards. And then we draw our arrow. Remember when I talked about array earlier on? That's what we're creating here, array. So we have a point, and we go from there, and then we draw an arrow. So make sure you do that, okay? Okay, let's do another one of these because it can get a little complicated. So here we have negative 2x minus 3 when x is less than negative 4. Once again, right here we have our restriction. Okay, so in this case, we can't just draw a very straight line. We have to start at where our restriction's at. Because really, this is just telling us that we can only go from negative 4 and then x value is smaller. And we can only graph our function from there. So make sure whenever you are writing your first point, your first x value, you always start with your restriction. So negative 4 is our number, so we have to start there. Now, to determine what other x values, you look at your inequality. This is saying x is less than negative 4. That means we want numbers smaller. So remember, numbers smaller means we want like negative 5, negative 6, and negative 7. Make sure you know what numbers are smaller than negative 4. That's going to be very critical. Okay? So now what we do is we take our x values and plug it into our function so we can get our y. So we start with negative 2 times negative 4 minus 3. And that should equal, so we have 8 minus 3, that should equal 5. There we go. Okay, we plug in negative 5, so we do negative 2 times negative 5 minus 3. So we get a positive 10 minus 3 when we do this, which should give us 7. Okay, then we plug in negative 6. We do negative 2 times negative 6 minus 3. Now, negative 2 times negative 6 gives us a positive 12. Remember, two negatives make a positive. And so when we do 12 minus 3, we should get 9. And then we have negative 7. So we do negative 2 times negative 7 minus 3. So this should give us 14. So we do 14 minus 3. And that should give us a nice 11. So we're going to go off the graph again. Now, before you even plot your first point, so negative 4, 5, remember, we have to see, does this have an open or closed circle, just like our inequalities. Now, you only ask yourself if your point is open or closed, only for your first point. Every other point afterwards will always be closed. Okay, it's only the first one you got to ask yourself that. So if we look at our inequality here, we have x is less than negative 4. Well, we don't have an equal bar here. So if we don't have an equal bar, that means we have an open circle, just like with our inequalities when we did it. Okay? So we have open circle. So we do an open circle on negative 4, 5. So we go over 1, 2, 3, 4, up 1, 2, 3, 4, 5. Make sure it's a nice open circle, not filled in. Now the rest of them are going to be filled in. So we go negative 5, and then we go up 7. Then we go negative 6, up positive 9. And then we go to negative 7. Oops, let me redo that really quick. There we go. So we went, negative 5, up 7. There we go. And then we went up 9. There we go. And then negative 7 is positive 11. Now remember, we always start from our first point we plotted, which in this case is the open circle. So we go from here and we connect the rest of the points. Okay? And then you draw your arrow. Make sure you are making what is called a ray. So you have a starting point, and then you connect the rest of the lines and make an arrow, because it does go on forever. Okay, so the rest of the examples, I'll put it in another video. Make sure if you have any questions on how to graph linear lines, especially with restrictions, you email me or come in before or after school, or you can ask your questions in class.